Gases are all around us. They are in the air we breathe and even in the soda we drink. Boyle's law, where pressure is related to volume and gives a constant so long as the temperature remains the same. Jacques Charles, Joseph Louis Gay-Lussac, and Amedeo Avogadro also found variables were related by a constant term. Charles discovered that volume is related to temperature and gives a constant so long as the pressure remains the same. Gay-Lussac discovered that pressure is related to temperature and gives a constant so long as the volume remains the same. Avogadro discovered that the number of moles in a container is related to volume and gives a constant so long as the temperature and pressure stay the same. In this laboratory, you will have the opportunity to demonstrate these laws. To demonstrate Boyle's law, you will be given a 6 ml syringe. Take out the plunger and spray about 2 ml of shaving foam down the barrel. Reinsert the plunger and expel the shaving foam into the bottom of a vacuum flask. Stopper this flask and attach a hose from a water aspirator. Turn on the vacuum when you are ready to observe. To demonstrate Avogadro's law, a setup is needed. Firstly, go to the sink and fill a large measuring cylinder with water. Leave the water running and cover the cylinder with an ice bucket. Invert this, then fill the ice bucket to halfway with water while it's running. You may then turn off the tap and carefully transport this back to your workbench. Secure the cylinder with a retort stand, leaving enough gap to feed the end of tubing under the rim of the cylinder. This is where hydrogen gas will travel along from a test tube that a 10 ml syringe of acid should be connected for reaction with the metal in the test tube. Once you have demonstrated these laws, you will relate them into a common equation with a constant term known as the ideal gas law. We can use this law for hydrogen gas to determine the identity of an unknown metal. But you will need to work out the values of some variables first. One of them is the pressure of hydrogen gas. To work this out, use the equation: atmospheric pressure minus water vapor pressure minus a corrective pressure value. Unless there is a barometer in the laboratory, we may assume the atmospheric pressure is 1 atmosphere. The water vapor pressure can be found on the back page of your laboratory manual and will be different depending on the measured temperature of the experiment. To work out the corrective pressure value, use this division, where the density of water and mercury are given to you in your laboratory manual. To measure the height of water, use a ruler. The 0 represents the water level in the ice bucket, and the meniscus in the measuring cylinder represents the height of water measurement.